All right. So when we have what's called a dilation, we're going to go back to our coordinate plane, just like we did before Thanksgiving. Okay? Everything that we did before Thanksgiving, the reflection, the translation, the rotation, those were congruent figures. Okay? Well, then we had to talk about what the heck a similar figure was. Well, now we're going to come back. We're going to do dilations. A dilation is going to take a shape and either stretch it or shrink it to where our result is going to be a similar figure. Okay? A dilation is pretty much a way that we force similar figures in the coordinate plane. Okay? Now, when we talked about similar figures, we talked about something called a scale factor. Okay? And the scale factor is how we knew how much bigger or how much smaller our figures were to each other. So I think the very first example we ever worked with was we had triangles that had a scale factor of 1/2 because one triangle was half the size of the other. Okay? So you are going to get a scale factor, and we're going to use the letter K. Don't ask me why it's the letter K. I have no good reason for you. I'm sure there is one. I just don't know what it is. Okay? But K is our scale factor. K for constant. Constant's not spelled with a K, just so you know. Yeah. Okay. Okay, now we are going to be able to tell if our figure is going to get bigger or smaller based on the scale factor. So what do you think is going to happen when K is a number bigger than 1? Is it going to get bigger or smaller? Bigger. Yeah. So that's called an enlargement, okay, which is a fancy word for it's going to stretch and get bigger, okay? So on the opposite end, if K is smaller than 1, then we have fancy word reduction, which just means it's going to shrink or get smaller, okay? No, it is not. Okay, Landon, can you multiply numbers? Yeah. All right, then I think you're going to be okay. Okay, so this is what you have, correct? You have triangle ABC, okay? Who can find the scale factor? What's our scale factor in number 1? 2. Ah, K equals 2. And because K equals 2, is our triangle going to get bigger or smaller? Okay, this is going to get bigger. It's going to be a stretch or an enlargement, okay? How much bigger is our shape going to be? Twice the size. Okay? This is literally all we have to do. We are going to take our coordinates. So A is -3, 4. And since our scale factor is 2, that just means, hey, multiply everything by 2. Do you know where it is? No, I was looking. Okay. Sorry, Mia. Okay, so what's our new A coordinate? Negative 6, what? 8. I literally took the A coordinate, multiplied both x and y by 2, and then I'm going to plot the new point. That's why the graph is there. But I numbered your x and y axes for you. You're welcome. All right, B, if we multiply B by 2, what's 2 times 2?
4.
4. What's 1 times 2? So our new coordinate is 4, 2. And here I am pausing to give you time to write it down and plot it. And then our C coordinate is -1, -5. So if we take both x and y and multiply them by 2, what's our new coordinate? -2, -10? I don't think that's a good thing to try right now. Hey, how much bigger is the red triangle on my screen compared to the original triangle?
2 times.
Oh, it's 2 times the size. That's what we're doing. Okay? So, first of all, do you have a question about this one?
No.
Okay. So in number 2, what is our scale factor?
4.
Our scale factor is 4, which means I'm going to plot my cute little parallelogram. But the parallelogram that we're going to get as a result is going to be how much bigger than the other one? 4 times the size. So could you, for me, right now, take these 4 coordinates and could you multiply them by the scale factor and put them here? Don't plot them yet until we agree that you have them right. But I want you to fill this out right here. What are the new coordinates going to be? Ready, set, go. Yeah. Yep, just go turn it in, yep. All right, so our new P coordinate. P is the coordinate 2, 3. With a scale factor of 4, Charmony, what does that become? What's 4 times 2? And what's 4 times 3? So our new coordinate is 8, 12. Okay. Don't be afraid. You got it. All right. All right. Awesome. Landon, what's the new Q? 16, 12. Because we take 4, 3, and we multiply both of those numbers by 4. Okay. Josie, what about R?
12, 4.
12, 4. Okay. we take 3 comma 1 and we multiply those numbers by 4. Okay. Kaylee, what about S? 4, 4. Okay. So here is the new S. Here is the new, I think that's P. Oh, 1, 2, 3, 4, 5, 6, 7, 8. Here's the new Q. Okay, so what I want you to do, take a moment and go ahead and plot those 4 coordinates so that your picture looks like my picture. We have the same 4 coordinates, we just agreed upon them. So take some time. The picture is important to have so you can see the visual of the pre-image to the image. Draw the next one. And why should I let you draw the next one? There's no numbers on here. Oh, sorry. Okay, I'll think about it. Oh, that's not right. Oh, there. Okay. All right. So, sorry. Had to get that done. Now, in number 2, how much bigger is my new parallelogram? How much bigger is the green than the black? 4 times. Now, I'm going to change it. How much smaller is the black compared to the green? How much smaller is the black than the green? 4 times smaller. So how would we say that? It's blank the size. Okay.
A quarter?
It's a quarter of the size. It's a fourth, right? Because instead of multiplying by 4, we would be dividing by 4. Okay? So here we go. In number 3, we have a scale factor of what? 1/2. Okay? So this scale factor of 1/2 means we have a shrink. Our new square is going to be half the size of this one. Okay? So you have 2 options. You can, just like we did before, you can multiply by 1/2. What is your second option? Or we can divide by the 2. Okay? So which one sounds better? Divide by 2 sounds better, doesn't it? Okay? But hey, you do you. Potato, multiply by 1/2, divide by 2. Same thing. So if we take 8, -8, and we divide by 2, what is our new coordinate going to be for E? Okay. 4, -4. Okay. Our coordinate for F is 16, negative 6. If we divide that by 2, we cut it in half. What does it become? 8, negative 3. G is negative 8, it's positive 18, negative 14. If we divide by 2, if we cut those numbers in half, what's our new coordinate? 9, negative 7. Okay. And then H. 10, negative 16. We divide by 2. We cut those in half. What do we get? 5, negative 8. Okay, so our red square that I have up here is now half the size of our original square. Okay? Landon had a question. We're not going to do number 4, but if we did, he asked, would we just divide by 3? What's the answer to Landon's question? Yeah, if we did number 4, we would divide all of those numbers by 3. So that's why you notice some of these graphs look a little wacky, because we have to have them big so that when we stretch our shape, we have room, or we have a big shape in order to shrink it down. Okay? So I would love for you to get your homework done before the weekend starts. So if you would also like that, let's get busy. On page 25, you have 5 problems to do. Find me the new coordinates and then graph them.